behavioral design patterns are all about events. Okay, so that's why they are called behavioral. It's all about events. And if you remember last year when you started Windows programming, C# and Windows Forms course, I think most of you like that because finally you escaped the console. So finally you were building forms, Windows Forms, which look more slick than the console. And the first thing that you needed to understand, okay, so this I think is the most important objective and added value of the Windows Forms, of the Windows programming course, is that in a very friendly environment, because .NET it's a very friendly framework, it's easy to use, and you have seen that, you have learned a very important principle that in all the applications, all the software that will have a user interface, there is this basic concept, this principle which is in all Windows applications, mobile applications, web applications. And this principle is about how the user interacts with the user interface. So you have a button. How do I interact with the button? I click on that, right? I just click on it. And then when I click on that, the software needs to do something, right? To open a new page, do something, whatever. So what's the basic principle that you all learn here? The event. Every time you put a control on the user interface, that control provides to the users some events: drag and drop, scroll, right click, left click, double click, whatever. And all these are called events, right? And what you need to do as a software developer is to provide a solution to that event. And then the framework will provide a user interface, and then when the user clicks on that button, your code will execute. So this was the most important principle in that course, because the idea was to teach you that, hey, we need to move away from the console where our programs look dummy and they all start with main and do whatever we say there in the source code, to a new type of software which interacts with the users. And then the users can click at any time on any control. So you have different ways to interact with that application. It's not sequential like you have in a console where you need to go through each step. No, here you can click 2 buttons in the same time. Okay, so all these patterns are about events. So in order to make a clear distinction, you will see that all the problems that will follow up are about handling events. They will all sound like this. You have an application which reacts to this event, or it's managing this event, like a fire alarm. And you want to change the fire alarm to call automatically the fire department and the hospital when something is happening, and so on. Or you're building an application, and when the user does that, the object or the software needs to do that, which means the software needs to react to that event. So again, it will be quite easy to distinguish between behavioral, creational, and structural patterns, because behavioral patterns are all about events. Okay, so creational are about creating objects, structural are about different relation between classes, and behavioral are all about events. So let's start with the pattern you all use since the first course you had during the Windows programming, and this is the observer. So the observer pattern, the problem is the observer pattern looks like this. You have some objects, right, in the in your solution. Now, these objects here are the buttons you have on your Windows form. Yeah. So you have how many? 6 buttons. And here, this is you. This is a function. and you are called the observer. So the function that you write, it's called the observer because you want to execute this function or other functions when the user clicks on these buttons. So here you have the event, which is what? User clicks on a button. And here you have a function or an object, which is called the observer, because this object has only one purpose, to execute that function when the user clicks on one of those buttons. Okay, so that's why you need a solution where the observer must be notified, must know when the user clicks on that button, which means the observer must know when the event happens. In the observer story, you have two entities. One is called the observer, the one which looks for something to happen, and the other entities which will say, hey, it happened, are called observables. Okay, so you have observables and the observer. In a Windows Form application, the observable was the button, was the list view, was the checkbox, was the radio button, was all those controls that the .NET framework provided you for free. And the observer was you, okay? Because you are writing functions and code, and you wanted to execute that code when that event happened. So these are the two entities in an observer story. You as the observer or the listener, and the observable, which is the entity which manages the event, okay? So I think if you think at that example, and then you did that another semester during the mobile app development, because again, you have seen that the same principles, but with different with a different framework, because you use the Android framework. And then you did that at Web Technologies, where you have used HTML controls, right? But it was the same idea, right? You had some controls and you wanted to do something on different events, like on click, on right click, on scroll, on drag, drag drop, and so on. So again, what are the advantages? The advantages is that here I can give you, and now this is the Microsoft team or the Google team which developed the Android framework. They can provide you controls, like very shiny, good-looking buttons, and you can actually do something when the user clicks on that button without actually changing the button implementation, right? So when you did all these courses, had you ever needed to change the button class? No. You were just writing methods and you were registering them for different events. So in this way, you see, this is solid. This is dependency inversion. I can give you a button class and you have the liberty to do whatever you want when the user clicks on that button, and you don't ever need to ask me to change something in that class, and you don't need to change something in that class, right? So the observer actually creates an independence between the event, the button click, and the handler, which is what happens when the user clicks. And this is deep dependency inversion, right? This is what dependency inversion says. Decouple things, so if you need to change something, you don't change the other one also. Because if you implement what you want to do in the click method in the button, then it means that every time you want to change that, you need to change the button class, right? So it's, again, solid. Okay, now, also the observer is implementing the Hollywood principle, don't call us, we'll call you. Why? Because this is based on the way the implementation is done. So here, the observer is notified when the event is happening. And that's why this is called the Hollywood principle, because, for example, if a user clicks on a button, the observer somehow it's notified. It's like the button calls the observer and says, hey, You're waiting, it's your moment. Execute, because the user just clicked me, which is the opposite of the observer calling the observable, which is the button, from time to time, like 2 times a second, and asking, hey, did the user clicked on you? Did the user clicked on you? So you see, you have these two ways of reacting to an event. One is to let know the observer, is to call the observer somehow and tell to that observer, hey, it happened, do it. And this is called push, the push approach. And that's why on your smartphones, you get from time to time from different applications notifications, and they use this push notification mechanism, which is actually the observer principle, which means they will send the message to you when the message is available. And the opposite is called a pull approach, when the client, in this case the observer, would ask with the frequency the observable, hey, it happened, it happened, it happened. Now, both principles have advantages and disadvantages, but the observer is implementing the push principle, which means the observable, the button, will notify the object, your method, to execute, and not vice versa. But just keep in mind that you have these two, let's say, strategies, pull versus push. Okay, and that's why the push approach is actually the Hollywood principle. Don't call us, we'll call you, right? Because we will let you know when the event happens. So how do we implement this? Now, this is the observer. So what you have here to the right on the screen is the framework, because you can have as many observers as you want, because this is what you create, and they need to be with the same type, which means no matter what classes you actually have here, they need to have something in common in order to interact with the observable, which is the button. So what you see to the left on the screen is the button, is the observable. What you see to the right is the observer. So here you can have any class with any name, but in order to use them in this pattern, they need to provide something common that the observable understands. And this is this interface here. So if I'm creating this button, and again, I'm going back to the Windows programming course, okay? The Microsoft guys, they provided you controls like buttons and other controls, but you know that each control was also providing you an interface like on click or click, which was actually telling you what, hey, if you want to write a function that you want to execute when the user clicks on this button, this function header should look like this. And in .NET, that was the delegate, right? So you need to provide this common ground. So here you need to have an interface which will have this method, like notify, do something, whatever. And if you want to take any class you have and make that class react to this event, you need to do only one thing, implement that interface. And that's all. So by doing that, you create an observer. So here you have an observer, here you have another one. Okay, so now you have a common ground. So any class which implements this interface can be notified. This is the contract. If you want to be notified, you need to implement this interface. Why? Because again, here you see a one-to-many has a relation. And what you see here is a collection of objects which implement this interface. That's why we need this common ground between the button and any class which wants to do something when the button says someone clicked me. So you need this interface, which generally is provided by the observable. So you have this interface, now you can define this collection. Now, when you have a collection, like we had with the composite, what do we need to provide? We need to provide a method that will allow any observer to register here to say, hey, I want to be notified. So this is the register. I think this was the name of the method in Android. You had something like register and unregister. And in .NET, you had the plus equals, right? If you remember in .NET, you had the event type, which was actually a collection of delegates, but it was actually an array of delegates. And in order to add something to that event, you were using plus equals, right? And you had that event plus equals the method or the object that you wanted to register there. So you need a method which will allow observers to register. Now, some observers at some point will say, I'm done. I don't want to be notified anymore. So you need to provide a way to unregister. So again, you need this method. So the third one is the trigger method. This method here is the method that the button, the observable, will execute when the event happens. This is click. Okay? So when the user clicks this method, the button will generate a sound, change the look, but then it will go through this collection of observers, references. So you go through this list, and what do? You call this method. And by calling this method, which is implemented in all these observers, because they all implement the interface, what do? You execute this method here, this object and this object. And this is the way you notify them. You actually call that method which executes in those observers. And that's the entire story. Okay? Now, in the Goff description, here you have an abstract observable, and then you implement the real class. But again, we know that in reality, developers are persons which they lack patience. So generally, you can do this class in one. Okay, you skip the abstract layer and you just define this class directly. We have seen that for the simple factory approach. We have seen that for decorators. So if you need only one decorator, you just define it, and that's all. Right? You don't define the abstract decorator and then implement the new class. Okay, so how the code looks like, and with this we close this meeting. So you have this example on, you will have it on Git in 10 minutes from now. So here, let's see, this is the class example with the button because I just mentioned it, and I know you remember this, and I hope you like this idea when you saw this for the first time at that course. So what do we have here? I have this button class, and the button extends clickable. Okay, and clickable, you see it has, so here I'm following the Goff. I have this abstract clickable observable class. So any control which allows users to click on them should extend this clickable. Okay, so or clickable. So what do I have here? I have a collection of handler click references. And if I check the handler click, it's just an interface which has this method do click or do something. It doesn't matter the name of this method, but the interface is important. And here I have this array list. Okay, now I have the register handler, which means if an observer wants to register and be notified, that observer needs to call register and handler and pass the reference to it, because then I will add it here in this collection. Again, some observers after some point will say, I don't want this anymore, get me out of that. So you need to provide unregister. Okay, so you just remove that reference. And this is the trigger method. So what do you do here? You see, because we know that all the references, all the objects which are registered here, they implement the handler click interface. I know they have the do click method. So what do? I go through that list and I say do click for those. And let's see, this is handler A. So this is a class, this is an observer which wants to connect to the database when the user clicks on the button. So what do? Implement the handler click, and in do click, you do what you want to do, connect to the database. Or here you have a handler B which wants to open login form. Again, I'm implementing the handler click and I do this in doClick. And now, sky is the limit. I can define any observers, any number of them doing anything I want. Okay, so if I want to do other stuff in the future, I don't change anything from what I have now. I just add new classes which implement this. Okay, and this is what we want to achieve, to add new stuff and not change existing stuff. Okay, so how do I test this? So I'm creating a button. So the button is just a class which extends clickable. Okay, and here on click, I do set click. Now you can simplify this even more. So you just call this notify observers, and that's all. So you can ignore here. At some point, I try to do something to show you that the button can have also a state. So, but just ignore it. So here you just do this notify observers, which is the trigger method from here, which you inherit because the button is just inheriting clickable. Okay, so we create a button. Okay, so let's back to test. Okay, and now I'm defining new handlers, new observers. This one was the one that tries to connect to the database. This was opening the login form. Then I register them. So here is where you did that in Android with register. This is where you did this with plus equals in .NET. And then, because here I'm still in a console app, I need to simulate that the user clicks. So this is the user clicking the button. Okay, this happens. So if the pattern is implemented right, what should happen? When this happens, all these handlers should be notified that the user clicked the button, and they should do their job, which means connect to the database, open the login form. So if I comment this part from here and run this example, okay, what happens? Sorry, I commented also the main bracket. Let's try again. Okay, what should happen? Button click, connect to the database, open login form, right? Because this is what happens. So I register, the observers are notified, they do their job. And it's transparent, right? So I don't need to go manually to each observer and do that. Now, if one of the, let's say, objects, observers wants to get out, I have unregistered, right? So if I unregister this handler and run the button click again, what should I see? That now only the connect to the database or button click, connect to database and open login form. But where is my connect to database? I think it's because I did something here with the state is clicked, and if it's clicked, it's not clicked. I'll just do this. Okay, so just ignore this one. Okay, let's run this again. Okay, yeah, you see it? So I have connect to database, open login form here for the first click. Then I unregister the B handler, which was opening the login form. So the next time the user clicks, I see only connect to database. Okay, so it's very flexible. I can add, unregister, register easily new stuff. And another advantage of the observer, and this is the way you coded in Android, but it's not clean, but was that generally in Android at the mobile course, mobile development course, I'm pretty sure, I bet that most of the time you provided observers or handlers for different events, you didn't create new classes. But what you did, you created anonymous observers. This looks very like the code you wrote in Android. Why? Because in Java, and this is specific to Java, you can easily create an anonymous class by trying to say new handler click. Yeah, but wait a minute. This is an interface or an abstract class. I can't create an instance of an abstract class or an interface, right? But when you do this in Java, what the editor is doing and you are allowed to do. You can open the brackets and actually define an anonymous class which implements the handler click interface or the abstract class, which means you need to override this. So this is a very convenient way of defining observers without adding new classes to your solution. Because maybe you say, yeah, I need only to do this, only here, I don't reuse it, I don't want to add another class in my project. So this has this advantage. But again, from a clean code perspective, it's not so clean. But let's say it's acceptable, right? And you did that a lot during that course, which is okay, right? Because you have seen that also over the internet and also in the official documentation. So this is another advantage of the observer that will allow you to register anonymous observers, which means are one-time observers that you need only there to do only some specific part. So again, this is an acceptable solution, but based on Gov, yeah, you should have also a class which clearly states, hey, I'm an official observer. But again, this is also acceptable. And I wanted to show it to here because now I think you understand that every time you did that at the Android course, you are actually using the observer pattern and you are actually creating an anonymous observer and registering that observer to an observable, which was that control that you wanted to use.